Cool. Welcome. Wow, 8 brave participants. Awesomeness. Let's bring this up. Cool. All right. So, let's see. Week 3. So I have graded PA1, posted some comments on that. But generally overall, PA1 looked really good. Most people either got a perfect score on it, or lost a few points for minor things, or if they lost significant points, it still looked like they had a good grasp on the notion of working with classes and objects. The two trickiest parts are the reduction using Euclid's algorithm, and dealing with division by zero. But those are kind of a little bit peripheral. If you can make a class, you can make constructors, you can just define methods and so on, then you're probably where you want to be Java wise. But if PA1, either you didn't understand your solution, or you weren't satisfied with it or something like that, right? Definitely come by office hours and let's go through your code together and figure out any missing details and such, and make sure that that's all squared away for moving forward. So how about PA2? Any questions on the word indexing program? Oh, well, start with one and we can go from there. And I'm planning to talk about hash maps, using the scanner class, using scanner to read in from files, and dealing with exceptions. Those are my 4 main ones. What will it look like to start the program? You mean how is it going to... So, if...
Might be easier to just say it.
Okay.
Can you hear me?
Yeah.
Yeah. So when we start how do we recognize what the name of the file is? Is it going to be that same exact file name, or is this going to take a command line argument, or that's kind of what I was asking.
So you're creating this class, right, which is called indexer, and when you want to index a file, you call the process file method, and you give a string as the argument. That's the name of the file that you're supposed to open up and index. Right? You're not writing a main program for this. All you're doing is creating the indexer class. So when you're testing it, you can do it, you can hardwire file names or take it from the command line or whatever is most convenient for you. But yeah, you're not responsible for a main program here. Let's see about the cleanup method. You can't use isLetter on a string, but can on a character. I figured a conversion from string to array character is unnecessary, but I guess I'm brain farting because I don't know how to do that. So you can do... Let's say you have a string word. And so you're going to get this from your scanner, right? Scanner.next is going to return a word. And so you can say word.character at some integer, and that will give you a character. And you can say is letter on that character of that word to see if that character is a letter. And so you can do all this inside a for loop, and you can say if this thing is a letter, then append it to an output string, and do that in a loop. So char at 0 will give the first character in whatever string you're calling it on. So if you say word.charadd0, that gives you the first character of the word, right? And then you can see if that's a letter, and if it is, then append that first character to an output string that you initialize to an empty string, and then set I equal to 1 and see if character at 1, which is the second character of the string, is a letter, and if it is, append that, and keep going like that. So word.charadd I is what we used to do in C by saying word bracket I, right? But it's not an array anymore, it's a string, so we use this character at to index the individual elements. Yeah, there's usually a pretty easy way to do this kind of stuff because these classes are very powerful and kind of feature rich. So if you find yourself writing a lot of code, you're probably reinventing the wheel. PA3, we will be reinventing the wheel to some degree, right? So that's going to be a lot more kind of codey. But for PA2, we're really kind of focusing on finding things that have already been made and supplied to us and then putting those together. So yeah, definitely use that to your advantage. And I saw some of this in PA1, where there was more work being done than maybe needed to be done. I also saw people getting into things like the this keyword, which we haven't talked about, and statics, which we don't really need to do. And if you're going down those paths, we should probably talk in office hours about what led you down those paths and why those might not be necessary, because you don't want to make life harder on yourself than it needs to be. And there's places where we're going to use the keyword this, but for the most part at this level we really don't need to worry about that. There's times when we're going to want to define a static method or a static field, but at this point probably not. Also, make sure that you're working from the command line, that you're using something like VI to edit your files. Some people are using different IDEs, BlueJ or IntelliJ or things like that. There's nothing wrong with IDEs, but they kind of rip you off on the opportunity to be learning this stuff while you're writing your code. And if you have to type in public static void main, etc., or class, file class name curly bracket, or the exact syntax for a for loop, if you type those things in enough times, you get muscle memory, and it solidifies it in your head, and when you get to a job interview or a closed book exam or something like that, right, it'll be second nature. So this is part of the reason for sticking with the command line. The other thing is, if you're using something that does like code completion for you or even auto indenting, it stops you from, it inhibits your fully kind of immersing yourself in what you're doing, right? If you really have to think about every character that's going into your program, you may end up with a deeper sort of connection to your code, which I think is really valuable for learning. So definitely stay away from the IDEs. I recommend just plain old VI. And if you've followed any of the videos or lectures on how to use VI, staying out of insert mode and so on, it should actually be a pretty efficient environment to be working in. So just some general ideas. Let's see, are we going to learn about for each and how to use it with hash maps? We can talk about for each. I was going to talk about iterators, which are kind of a lower level way to iterate through a hash map, but you should not need to use iterators or for eaches for PA2. You shouldn't have to go through your hash, really. You just need to take a word, see if it's in the hash. If it's not, create an empty linked list and then append to the end of that linked list. Counting the number of things in the hash is really just calling the size method on the index object, and doing the toString is really just index.toString, just defer from the hash maps. toString. So we'll see what those mean in code in a few minutes. When counting the amount of times a word appeared. So if you have an index and you have a word and you want to know how many times it appears, you can say index.get parentheses word. That's a linked list, and if you say .size, that'll tell you how many entries are in the linked list. That's how many times the word appeared. So again, you don't have to really do any work. You don't have to loop through and count or anything like that. Number of times the word is in there is just the length of the linked list, and that we've got a method for. So yeah, at this point, it's going to feel almost like cheating when you're actually, getting down to working with objects and classes to their full potential. It may actually feel like, you're getting away with something when you can write this instead of making a loop and comparing and counting and all that kind of stuff. That's the reason we do this, though, right? Because when you're working, in industry, for example. You don't want to have to spend your time, implementing a linked list or things like that. You want to use those to do bigger and better things. But it takes some getting used to, after 121, 224, 223, 270, all this stuff where we're working at such a low level, all of a sudden we're at a totally different style of programming where it's just like, give me one of these and give me one of those and let's put them together. Here you go, So yeah, it takes some getting used to. All right, so let's go back and revisit the scanner class, and we played with scanners last week to look at reading in lines of text. So let's tweak scanner a little bit. Let's read a word at a time, because that's part of what we have to do for PA3, and then let's use that to look at how we do input from a file instead of from standard in. Yeah, it is week 3 already, and that's pretty crazy because things are moving along. Well, they just published the fall schedule of classes for September, so yeah, things keep on moving. What should we call this? Let's call this scan. So, we're going to make a scanner. Summer courses are still primarily remote, so there may be exceptions like, diesel, for example, but like Engineering 270 is going to be remote or online, I think, depending on which section you take. Some classes will be partially face-to-face in fall. So we'll construct a scanner, and for first passes, we're just going to read from standard in, so system.in. And last time we did sc.hasNextLine, which tells us there's another line of input available. HasNext will just tell us there's another word of input available. Okay, where words are things separated by space. So while sc.hasNext, that tells us there's another line. And so we can read, let me call it word, because that's what I did in my notes. And we can read that next word by using the next method. Alright, so word equals sc.next. Alright, and then we'll print out what the word is, and we'll just hang out here in a loop. And when we're done with our input, we'll close the scanner, and that should just be a basic input loop. Is WSU totally face-to-face next fall? I haven't heard. It's a mix, okay. Okay, that makes sense. All right, so here's this. This is almost the same thing we did last week, right? So you need an import statement from Java utility, and if we compile this up, and we run it, right? So it basically tokenizes your input. It breaks it into words, where words are things separated by spaces. So this is a test. So if my input is something like hello, X, can you hear me, right? It's the stuff in between the white space. So hello, comma is a word. Me, question mark is a word, right? So in PA2, what do? You get those words by using, scanner.next, and then you go through, you convert letters to uppercase, you throw away things that aren't letters, according to is letter, and that gives you your words that you're going to put into your index. So hello, can you hear, and me. Cool. Yeah, driving is awesome, man. All right, so so that works well by itself. And the scanner class will do a lot more for us. So we've used, next line and next along with has next line and has next, but there's all these other things. So we can say, does it have a next byte? Does it have a next double? Does it have a next float or a next int? And we can break up our input and do some rudimentary parsing. For example, if you're looking for, a word followed by a space followed by a number, we could do has next and then has next int, right? And as long as they put in a word and an integer, this should return true, and you can pull those off with the corresponding next or next int or next float and so on and so forth. So it's kind of taking the place of, like, what we used to do with %d, %f, %g when we would use scanf. So PA2 uses scanner heavily. Not really. Yeah, it gets the things you implement into the hash. So really, you just need one spot where you're going to have to create a scanner, right? And then your main loop's going to be, while there's another word, get the next word. So while sc.hasNext, word equals sc.next. So something like that. And then what do you do with the word? Clean it up with your cleanup word method. See if it's in the hash. If it's not, put it in the hash with an empty linked list, and then add your position counter to the end of the linked list associated with the word. So not really too scanner intensive. All right, so what if we want to do input from a file? So we can still use the scanner class. Now there's a lot of ways to do input. Okay, there's this huge hierarchy of classes related to doing input and output. This is one way to do it, and it works great for everything we're going to do, including network stuff. Scanners for input and then print writers for output. But there's other things that we can do. On PA3, probably mean PA2. On the edge case, this thing is one item, should be an empty string and therefore not add on the list. That is perfectly correct, yes. If your word separated by spaces doesn't have any letters in it, then when you clean it up, you'll end up with an empty string. So always check to see if your string is empty. If it is, don't add it to the index. Just go back, get another word. I think that's the only really weird edge case. And that will pop up, if you have like text and there's like a hyphen, separated by spaces or something, that would show up as an empty word. But yeah, I think that's probably the main one. All right, so if we want to use scanner to input from a file, So first of all, look at the scanner class, and if you look at constructors, one way to construct it is by using what's called a file. Right, so it constructs a scanner that produces scan values from a specified file. So what is file? File is a class. And one way to construct a file is to just give it a path name. So you can put in a path. It can be a relative path, an absolute path. It can have dot dots and tildes, all the usual stuff, right? But you put that as an argument to the file constructor, and you get back a file, which you can use as an argument to the scanner constructor. So this all goes together really nicely. So let's open a file, and instead of system.in, let's say new file, and we'll call it data.txt with an extra closing parenthesis. Alright, so what's going to happen here? Data.txt is used to construct a file object that's used in the constructor of a scanner object. So when we're done with this, SC should be a scanner that is pulling in input from this file. And you might observe here that, you know, we're constructing a whole new object. We're constructing this file object right here. We don't really have a handle to that object. We're not saving it in a local variable, right? We're just passing that object directly to the scanner. The scanner has access to it. We don't. We don't care, right? We don't have to do anything with the file that's constructed by this constructor other than give it to the scanner. So we can just do this in line. And this is also pretty typical in object-oriented code, where you start, you know, stringing these things together, and you're doing things like, you know, index.get.size, right, or word.carat.isLetter, right, that kind of thing. So sometimes temporary variables are nice for debugging, if you want to print values out, or you know, be very fine-grained in how your code progresses. But sometimes, right, it makes sense to just kind of do things in one line. How do we want to clean up the deal with this? Hello.head.low question mark. If there is a space in there, then it's going to be 2 words. If there's not a space, then it's going to be 1 word. So your words are things separated by space. And don't do any extra work. Just use scanner.hasNext and scanner.next. Right? That will tokenize your input into words, and then just throw away everything that's not a letter. Make everything uppercase. And I think the test file in the assignment gives you some examples of that. All right, so this will almost work, but it's not going to compile quite right. First of all, I need to do an extra import for files. So go to the top of your documentation, and you'll see a file also comes from java.io.file. So let's put that in. But it's still not going to quite compile. So it's giving me a new message here. It says, unreported exception, file not found exception, must be caught or declared to be thrown. And it's complaining at line 8 of my file. So if we go down to line 8, that's where the scanner's being constructed. So let's go back to the scanner documentation and look at this constructor, and I'll click through to it. And in here, what do we have at the bottom here? Throws file not found exception if source is not found. All right, so exceptions. So what's an exception? It's something exceptional. It's something that wasn't expected, something unusual. So what causes exceptions? Well, you know, if you try to open a file and the file doesn't exist, that's not what you were expecting. That'll throw an exception. If you're calculating a divided by b and b turns out to be 0, that's an exception. If you're calculating square root of x and x turns out to be negative, that's an exception. If you're accessing an array and your index is too big or too small, that's an exception. And the thing with exceptions is, because they're unexpected, because they're exceptional, it can be hard to prevent them. For example, every time that I calculate a quadratic formula, right? So I want to calculate the root of an equation, right? Before I do this, I could put an if statement. And I could say if a is equal to 0, you know, print out a message, right? That's a real pain to do. And it takes time and it takes code. And if we're not expecting to divide by 0, we don't really want to like spend time checking to see if that's 0. So you know, if this happens to do a divide by 0, it'll throw an exception. And an exception usually terminates your program. It's basically like an interrupt, but it's triggered by software instead of hardware. So if you've done 270, an interrupt pin, right, or a timer expiring, or an A to D conversion completing, those are interrupts. They change the flow of your program at the machine code level. Same thing here, right? The floating point unit that's doing division will throw a signal saying, oh, we got to divide by 0, and that'll basically generate an interrupt. All right, because we can't always check for these things, right? I mean, we could check to see if this file exists first, but that's a pain. So we let the system throw interrupts. In C and other languages, some other languages, right, when an interrupt happens or an exception happens, your program just throws up. Java forces you to acknowledge that an exception could occur and tell it what to do if something does go wrong. So we have what are called try-catch blocks. So let's say we're doing some statement in Java, and we think it might cause an exception. So what we do is we put this inside curly brackets with the keyword try. So we say try to do this statement. And if it throws an exception, instead of just exiting my Java program completely, come down here to this catch block and do whatever statements are in here. Something went wrong. So try to execute this statement. If it succeeds, it'll ignore the catch block and just continue down here. But if something goes wrong in here and it throws an exception, instead of giving up, it will jump down here to this catch block and start executing these statements. So it's a very controlled way to manage unexpected situations. Now in this catch block, it kind of looks like a function call. We put an argument on here. And the most general argument is going to be a single argument of type exception. And more often than not, that variable is just E, but that's just a variable name, right? I could call it whatever, and then I could use whatever in here, and that would be the exception. And this is a structure we'll see a lot in coming weeks. We'll create, you know, a method or something that looks like a method, and when that gets called, information about the current situation is passed to this code through the form of an argument. Right? In this case, once we're inside this catch block, I've said I want this variable E, this object of type exception, to tell me something about what went wrong. Alright, so try catch blocks. We'll use them anytime that there's a possibility of an exception, a reasonable possibility of an exception. Now I could put a try catch block around here, or I could just leave it without, and it'll let me compile this without insisting that I put a try catch block. And if A turns out to be 0, my Java program will print a message and exit. But if I'm worried about that, if I really want to make sure that, you know, this doesn't terminate my program and I don't want to check this by hand, I could put a try right around that statement. Alright, so let's embellish this, and you know, it won't compile unless I do that catch. Must be caught. Or I can describe this entire method as saying, you know, this method might throw an exception, and then something else that calls this method has to catch that. So let's use a try catch block. So I'll say try, and I'll put that And then here's my catch block. So I'll say something went wrong and I'll return, and we'll leave it like that. Alright, so what's the mechanics here? Instead of just opening the scanner blindly, I'm going to open the scanner inside a try block. If it succeeds, it'll come down here and it'll do my while loop. If it fails, if it throws an exception, it will jump down here into my catch block and it'll say something went wrong and then return without all kinds of horrible behavior. Okay, that's the basic setup for a try-catch. We'll do that again and again and again. And this will almost compile, but not quite. And it gives you a kind of weird message. It says, SC cannot find symbol. And why can't it find the symbol SC? I declared it right here. SC is a scanner, and I'm setting it equal to the return of this constructor. So we have to keep in mind scoping. So scoping is the notion of in what space does a name exist. For example, inside this method, if I make some local variables like integer I, j, k, those don't exist outside of this method. They're local to that. If I define a variable up here, right after class scan curly bracket, integer flag, flag exists throughout that entire class. Okay? The scoping in here of SC is strictly inside this block. It's as if I was inside a for loop or a while loop. You can declare variables inside for statement, but they're local to that loop. So right here, SC is local to this block, which means when I come down here, it doesn't know anything about SC. And if you're using an IDE and you type a statement like scanner SC equals, and it says, you know, this can throw an exception, should be surrounded by a try-catch block, right? It may simply put a try-catch block here, and you'll start getting these errors about, you know, this object is undefined. So the easiest, quickest fix for that is just declare your scanner outside instead of inside. So now, by simply declaring it up here, it's defined within the entire scope from that curly bracket to that one. And then I simply use that SC, so here when I say SC equals return from the constructor, it's this scanner object right here, which is the same one that this will try to access. Okay, these are just little nuances that may save you like a few hours late at night if you're hitting your head trying to figure out why it doesn't know where SC is. But nothing too magic. Alright, so now we try to compile it. It compiles successfully. And when we try to run it, it says something went wrong. Well, something went wrong is the message from my catch block. So let's see what went wrong. Let's print out that object that was given to the catch block as an argument, that exception E. So something went wrong, data.txt, no such file or directory. So that's perfectly fine as far as clarity, right? I tried to open data.txt, it doesn't exist. Yeah, this is a really good reason to indent code. This declaration of scoping. Alright, something went wrong, yeah. So there's no data.txt, so let's make a data.txt. And now when I run this, it ingests my file one word at a time and prints out each word. Alright, so that's really all there is to it. And if I make my file unreadable, it'll tell me something went wrong, file not found, exception, data.txt, permission denied. So it's pretty good, you know, level of information in there. And so this exception thing, right? Exception is a class. And it has all of these methods available to it. For example, we can say print stack trace, right? And print stack trace will print a backtrace of the current context of your program. So we can let's call e.printStackTrace, and then say goodbye. Right, so we got an exception. We printed out our message, something went wrong. We printed out the meaning of that exception by just turning e into a string with a toString method. And then we called the print backtrace method of e, right? And you know, when we get an error, it's like we run into this whole chunk of code, but we have this object e which has all this information about the current exception, the current context of our process, and which has all of these methods available that we can use to interrogate, you know, what's going on. And so in this case, we used the print stack trace method, and it gave us a call frame history saying that, you know, the exception occurred at line 10 of scan.java. And at line 10, we were calling scanner.java, and we got down to line 611 of that. And that made a call to file input stream at line 138, which made a call to line 195, which made a call to open0, which is a native method. That's a low-level thing that's part of the JVM installation that's doing the low-level I/O. Right? So most of this stuff is you know, stuff we did not write, but if we had a bunch of things calling other things, right, we could see the whole call frame history here, and that can help us figure out what's going on. Yeah, so I don't know if you could do try catch for memory leaks. That would be interesting. Like put your whole JVM in a big try block or something. All right, so you know, thinking of objects, right? And this is just another object. Oh yeah, that would be cool. Totally. All right, so that's enough try catch to get you going on being able to use scanners to read in from a file to put that part of your process file method together. We can catch, you know, different kinds of exceptions because exception is one exception. Right? It's a Java language throwable, but it has all of these other specific types of exceptions, right? Such as I/O exception and line unavailable exception and a Marshall exception and all of these other things. And we can create a try-catch block which says, you know, if you got a bad location exception, then do this set of code. If you got a destroy failed exception, do this other set of code. And so we can get very detailed in how we want to handle different types of exceptions, and we can also we can put a catch-all block at the end that will fire regardless of whether there's an exception or not. All right, So that's enough to get you going with that. Let's take a look at hash maps. And I told you should get practice writing this stuff, but I don't feel like practicing, so I'm just auto-generating this stuff. All right, so hash map. So hash map is generic, right? We specify the type of objects for the keys and for the values, and we have to tell it both. And remember the basic structure here is this associative array with key value pairs. And for PA2, your keys are going to be strings, your values are going to be linked lists. So let's play around with this. Let's make our keys strings, and let's make our values rectangles. Because why not? Oh man, I've been doing all that stuff in my top level directory. Oh well. Alright, so there's our rectangle class. Let's play around with our mapper. So we're going to import from Java utility hashmap. And we're going to construct a hash map. Alright, so in the declaration of our object, we have to specify in angle brackets the types of things that this will work with. So we need the key value pair. So it's going to be a string and a rectangle. And I'm just going to call this my map. And I'm going to construct it. And so when you construct, you also need to specify the values for those generics. So this is going to be a string and a rectangle. Now I can do this all in one line, or I can do it in 2 lines like this. I'm just choosing to do it in 2 lines for no reason. So I'm making a hash map called myMap. I'm constructing it with no arguments because I don't need to specify anything to my constructor. If you want to specify an initial size, you can do that. If you want to specify the load factor, CSE223 pop quiz. Do you remember what load factor is for a hash? So load factor is basically how full the hash can get before you consider that it needs to be expanded. So if half of your cells are filled up, is that full enough that you want to go ahead and make your hash bigger? And there's settings for these by default, and they're usually pretty good. But if you know, for example, that your table is going to grow very quickly once it reaches a certain point, you could adjust the load factor accordingly. So you can do all these things, right? We're not going to worry about any of that. We're just going to make a hash map, no arguments, and let's put some stuff into there. So there's a put method, which takes a key and a value pair. So let's put some things. So my map. All right. So let's put some rectangles. So somebody give me a name for our first rectangle. 12. And just to be ironic, we'll make it a 1x13 rectangle. All right, somebody give me a name for a second rectangle. Greg. And I don't know, We'll make that one 25 by 25. Square. We'll make that a 1 by 1. Greg the second. Call it Greg 2. We'll make that, 52 by 52, of course. And let's see. Yeah, spaces are fine. All right, so regress. Don't want to upset Greg. So the only thing that can be tricky with these is having a key that's null. And there's hash maps and hash tables, and one of them lets you have null keys, the other one doesn't. I don't remember which is which, but we don't need a null key anyway, because our keys are going to be words, right? But they can have spaces in them. They could have non human readable characters, anything you can put in a string, right? So this will construct a map. Doesn't do much. Oh, I still got my data.txt. Right. So it doesn't do a whole lot. Well, especially if I don't call it. Ooh. There we go. All right. So it makes a map. It doesn't do anything. Hash map allows null keys. Okay, cool. Thank you. That's a really good question. It didn't seem to want me to put those characters in. Yeah, but you'd be surprised what you can get away with Unicode. So there's probably a way to make a smiley face. All right, so so we've got some stuff in the map. What should we do with it? Let's print it out. All right, I'm just going to concatenate it to a string, which means it'll call the toString method of this hash map. And look at this, right? 12 is a 1 by 13 rectangle. Square is a 1 by 1 rectangle. Greg 2 is a 52 by 52. Greg the third is a 3 by 33. Greg is a 25 by 25. Right? And guess what? This is the format that you want for PA2 when you call the toString method on your index. So you don't have to do any work for your toString method. You really just need to return index.toString. And the way that a hash map is converted to a string by its toString method, that's exactly the format that you want for your word indexes toString. All right, so we can toString pretty easily. Now suppose we change square to be a 1000 by 1000 rectangle. Right, so up here I put in square as a 1 by 1. Down here I'm going to put in square as a 1000 by 1000. And I don't get two squares, right? Square got replaced. Because the put method will add something to the hash map if it's not in there. It will replace it if it is already in there. We don't have to do that though, right? For PA2, we put something in. If it's not found in there, we put in an empty linked list. Otherwise, we get the linked list and we just append to the end of it. So how do we get something from the linked list? Use the get method. So if you have a word, you can say index.get parentheses word. That will give you, for PA2, a linked list. And then you can call its methods. Alright, so that's the basic setup for hashmaps. So I put a version of this already on the shared code area. I'll push this one up also. But that's really all there is to it. Alright, so mess around with that. Come up with some questions, ask those tomorrow. And we'll continue from there. Oh yeah, and the output order is completely random, right? So we can't control that. But fortunately, I didn't ask you to alphabetize your words or anything, so you're in luck. All right, so we'll talk about iterators tomorrow. That's another way to go through the elements of a hash. All right, cool. Have a good one. I'm going to answer some questions from chat, but you're free to go. I will see you tomorrow. Is indexer.class in/temp our template for testing our code against the PA2 standard? Indexer.class in/temp is my version of what you're trying to write. So it's not a main program you can use. There's a main program in the assignment prompt, but indexer.class is what you're trying to come up with. So if you have your own main program, you can run it against indexer.class in/temp, see what it does, and then run it against your indexer and see what it does. And it should do the same thing, unless I messed up, which is possible. Yeah, you're welcome. Yeah, open source code is good that way. Definitely. All right, cool. Have a good one. I will see you tomorrow.